LD is cracked. Time to get into this. So what is Newtonian determinism? Let's first start with a little bio on Isaac Newton. Newton was born January 4th, 1643 in the UK. Newton was not just known for his luscious locks, but he was a mind of revolution. Newton created the foundation for classical physics, first with discovering his 3 laws of motion. The first law being inertia. By definition, inertia is the resistance of any physical object to any change in its state of motion. Example being, you're driving down the street, a deer jumps out in front of the car, you got your backpack in the passenger seat, you slam on the brakes, and that backpack keeps going. That's inertia. The second law being force, mass, and acceleration. This, by definition, is the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So example being, the force it takes you to push, say, a 10-pound wagon down the road at, say, 5 miles an hour is not going to be the same force it's going to take you to push a 100-pound wagon down the road at 5 miles an hour. It's going to take more force to push a heavier mass. The greater the force, the greater the acceleration, but the greater the mass, the less the acceleration. And then the third law is the law of action and reaction. I feel like this is the most popular law. By definition, it is for every action, there's an equal and opposite reaction. Example, you shoot a gun. The action is the bullet accelerating through the air. The reaction is the gun recoiling. Next, we're going to talk about his discovery of universal gravitation. This is the description of the fundamental force of attraction between any 2 objects of mass in the universe. It's the force that keeps all of our planets orbiting around the sun, the moon orbiting around us. It's the same force that keeps our feet on the ground, and I mean, if you're unfortunate enough to fall, it's the same force that's going to drag your ass to the floor. The last discovery we're going to talk about is Newton discovering calculus. Now, he discovered calculus out of pure necessity, because the equations that he was doing to understand instant rates of change, traditional algebra was not complex enough to solve these problems. So he invented his own math, which is calculus, to further understand this, and this allowed him to just overall understand motion better, or more accurately, as I should say. So now back to why we're even here having this discussion. What is Newtonian determinism? So I'll give you by the definition of what it is first. The principle in classical physics that the future state of a system is completely determined by its present state, provided its position, velocity, and the force acting upon it are known. So now what does this even mean? Right? Newton believed that the universe around us, it was all governed and ran by mathematical laws. So theoretically, if you knew the conditions of all the particles in the universe, right? If you knew the position, the velocity, and if you knew the force that is acting upon it, you could technically and theoretically, you could make predictions accurately of what's to come in the future, what's going to happen, what are the events of the future. So now this is where I get pretty excited. That last notion I was just talking about, right? So Newton believed if you knew the conditions of these particles, okay, if you knew the position and you knew the velocity, you can make these predictions. So if your quantum brain is firing here and thinking, if that part of your brain was firing like it was when I was researching this, something immediately popped into my head and why this is a problem, knowing the velocity and the position of a particle, right? It brings up the Heisenberg Uncertainty Principle, which was discovered in 1927 by Werner Heisenberg. So this is where quantum physics comes into it. This principle states, I'll give you by the definition again, okay? It's fundamentally impossible to simultaneously know both the exact position and momentum of a particle with perfect accuracy. Okay, so this immediately, when I read that Isaac Newton is making this claim on knowing the exact position and velocity, Werner Heisenberg popped into my head, right? And I'm going to show you, I think I have the diagrams, but you have 3 options. So essentially you have 3 options, right? You can know the position, you can know the certainty of a position of a particle, but you're uncertain about its momentum. You can know certainly the momentum, but you are uncertain about the position. Or you could be uncertain about both. So there's a funny joke that I heard Neil deGrasse Tyson say. Werner Heisenberg, he gets pulled over by the police. They ask him, "Hey, sir, do you know how fast you were going?" And he says, "I do not know how fast I was going, but I know exactly where I'm at." Okay, that's neither here nor there. We're moving on. But I'm pretty sure I wrote the diagram down. Okay, if you look with this top wave function here, okay, you're certain about the position, you're uncertain about the momentum, you're uncertain about both. This one, you're certain about the momentum, but you're uncertain about the position. So that is the Heisenberg Uncertainty Principle shown in wave functions. So, therefore, Heisenberg contradicted Newton's beliefs. Isaac Newton also believed in absolute time. You know, he believed like when the world started, bang, a clock started. It's just time is the same everywhere for everybody, no matter the observer, no matter if you're in space, if you're on Earth, it's all exactly the same. It's like as if a stopwatch started when all this was created. But then we know Einstein came along and contradicted that as well, obviously. But that's just, to me, that's the beautiful thing about science. It's just a constant working and reworking of theories. And for hundreds of years, Newton's beliefs and his theories were, I wouldn't say sort of, they're technically not correct, but they were what was believed at the time. And then through science and just through constant innovation and scientists working, we disprove things and we prove other things. And we never know. Some of this stuff might be disproven 100 more years down the road. So that's just the exciting thing about science. It's constantly moving. For somebody to be right, oftentimes somebody has to be wrong. That's okay, because take Newton, for example. He's a fucking genius, okay? He's a genius. But because he was wrong, Einstein was right, therefore giving the human population, the human race, the correct answer. Einstein's theory of relativity is the correct answer on time. Time is relative. It is not a constant. So it's just exciting to be interested in, because it's constantly changing. So there's new information coming out, and you're just, it's not like you're learning about one specific thing in history that happened and you could only learn so much about it. Science is forever evolving. But thank you for tuning in. I hope that kind of makes the Newtonian determinism a little bit more understandable. I enjoy making these videos. They're a lot of fun because I enjoy researching this type of stuff. So it's fun to be able to flesh the idea out and then speak it and see if I do truly understand it. And it's nice because I may be wrong. I might have said some stuff wrong, but that's the beautiful thing about the internet, is you people could tell me I was wrong and we could all fucking learn together here. So nonetheless, I will talk to you guys tomorrow. Peace.